Okay, sorry, I'm running a little bit behind here. Would you mind shutting the door? Thank you. How's everyone today? This class seems like it's shrinking, doesn't it? 2, 4, 6, 8, 10, 12, 13. Out of 20, I think we started with 20, 24 or something like that. So, interesting. Well, you're here. That's all that matters, right? We ended class last time in Chapter 6, Section 1, talking about GCF, right? And just to get you warmed up a little bit, if we had something like this, 2x times 5x plus 1 minus 5x plus 1, the idea that I was trying to get across towards the end of class, and if you did your homework, you would have seen several of these examples, was for you to recognize that with these problems, if what's in those parentheses is identical, then that becomes your GCF, and you factor that out, right? So my GCF here would be the whole thing, 5x plus 1. And then what I can do is I can write that GCF on the outside, and then I put a set of parentheses, and I need enough room in those parentheses to put how many things? 2, right? Because I'm going to need to account for this piece and this piece over here. So it's almost like a binomial. So what's missing on the first piece there? The 2x, so I had to multiply by 2x. And then be kind of careful on this one. What's missing on the second? Whoa. A minus 1, good, because there's really a negative right there, a negative 1 right there. So that's a minus 1, so I have to put minus 1 here. And then we'd be done, right? We box that up, and that's our answer. So that's what we did at the end of class last time, right? Okay. Now today we're just going to continue with this, but I'm going to give you a different type of problem. I think you'll see almost right off the bat that this is different than what we've done up to this point. And I think I'll work a few right out of the book. Try and stay somewhat consistent with what they're asking you. So how about this? What if you had factor x squared plus 3x plus xy plus 3y? Yeah, so let's start by first recognizing that we have a total of 4 terms here. 1, 2, 3, 4, right? 4 terms. And let me try and find a GCF, because that's always our first step for factoring, a GCF in all 4 terms. So are there any numbers that go into all of these? Just 1, right? And we said whenever we add 1, we don't care. Now, how about variables? I have an x here, I have an x here, I have an x here, but I don't have an x in the last term. So I can't factor an x out. How about y's? Only in the last 2 terms, right? Not in the first 2. So we don't have a GCF of y. So that means as far as GCF is concerned, I have none. So what we're going to be talking about today is a new method that we use when we have 4 terms. And it's a method that we're going to try. We'll see later on this method does not always work, but when it does, it makes things pretty nice. So if we have four terms and we have done a GCF, right? We've already done a GCF here. We tried, nothing happened, but we did address that. So if we have 4 terms and we have done GCF, then we try something called grouping. Grouping. And I will stress the word try because it may not work. And when it doesn't work, then you have to try something different that we won't try in this class, but when you get to college algebra, if you do a problem and grouping doesn't work, they will introduce you to a new method. And believe it or not, it's going to involve synthetic division. Remember synthetic division on your test? It'll involve that, but it'll take a good week for your instructor to explain how it would work. Okay? So, but this is what you should walk into college algebra being able to do. 4 terms, try grouping, and then hope for the best. Okay, so how does grouping work? What we do is we take a look at our 4 terms, and different instructors do this different ways. Okay, so if you've seen this before and I show you a way and you're like, I don't like your way, I like the way I learned it before, then that's fine. But this is the way that I do it, all right? With grouping, what you do is you take 4 terms and you split them in half. So instead of looking at it as 4 terms, you look at it as 2 and 2. And where you split it is immediately after the second term. So I have my first term is x squared, then I have plus, my second term is 3x. Right after the x, I'm going to draw a line that separates the first 2 and second 2. The important thing here is that this sign right here, the plus, don't split it on the other side. Okay? Like if that was a minus, you wouldn't want that blue line on the right side, you want it on the left side of the minus. Okay, so split it right after the second term. And then, don't write this down, but just watch what I do. Just act like that's not there at all. Okay, don't do that to your page because you need that side in a minute, all right? But just ignore it for a second and just look at the left side. On the left side, is there a GCF on those 2 terms? Yes. What is it? X. So do a GCF factoring on just this. So you would pull your X out, right? You would have to leave enough room in a parentheses for what? 2 terms, right? I'm going to move this down a little bit. X is here. I leave enough for 2 terms. Now, what would I need to multiply x by to get x squared? X, what do I multiply x by to get 3x? Plus 3. Okay, so what we've done is we've done a little like miniature GCF in this problem. Then what we do is we act like the left side's not there, and we do the same thing to the right side. Our goal, though, keep this in mind, our goal is to try and make, see this x plus 3 in parentheses? We're trying to make another x plus 3 appear over here. Because what if there's an x plus 3 here and an x plus 3 here? Then we do what we did first problem today, right? So the different ways of attacking this, like I said, different instructors teach it different ways. One way is just look at this and say, what's my GCF, right? Which would be what? Y, and you pull that out, whatever. Or you can look at it this way. What you're hoping for is this, right? That's what you're hoping for, so that they match. And then you can ask yourself, what do I multiply that by in order, that's a question mark, in order to get this to become this, and then multiply here to become this. So how do I turn x into xy? I need a y, right? So let me just throw a y out there and see if that would work. Will y times x give me xy? Will y times positive 3 give me 3y? Yes, so it works. What if for some reason you multiply this times this, you get xy, but you multiply this times this and you get 4y? Then it wouldn't work, right? But in this case, it does. So do you see now we've done 2 like separate problems? Yes? There's one critical step left. If you leave it like this, it looks like there's multiplication right here. But there's actually either addition or subtraction. And it depends on what you pulled out. I pulled out a y, right? Not a negative y. It's a y, so we're going to treat it as a positive y. So I need to include in between those a plus. On your test or on your quiz or whatever it is I give you, if you forget that, I'm going to take a point off. I mean, just a little bit, but it's so important for you to understand that there is addition or subtraction between those two pieces. And now, bless you. Do what? So now we recognize we have x plus 3 in both, right? And so that's now our GCF. We pull that out in front. And then what's left? X plus y. And this should be our answer. Y'all see how that worked? Now, we said last class, or I said last class, that the good thing about factoring is that you can always check your answer. So I'm going to do a check here just to convince you that this did work. X times x would give me x squared. X times y would give me plus xy. 3 times x would give me positive 3x. And 3 times y would give me plus 3y. Is that the original problem? This is this, but it's in a different order, right? But it's the same thing. X squared, I have x squared. Xy, I have xy. 3x, got 3x. 3y, 3y. Any questions? How many of you have seen grouping before? 2, 3. Let's try another. How about 6ax minus 6ay minus x plus y? Instructions here are to factor. Basically, we're going to be factoring for the next week and a half, so I'm kind of implying factoring here. All right, so when you look at this, you say, I have 4 terms, right? I'm going to look for a GCF first. Do I have a GCF to start? Well, there's no number that goes into 6, 6, 1, and 1 other than 1. Do I have variable that's common? I have a, but no a's over here. I have x here, but no x's here. I have a y here and here, but nowhere else. So I don't have variables across all 4 that are in common. I don't have numbers. Agreed? So then I'm going to decide, because it's 4 terms, right, to try grouping. So where do I put my division? Not division, but where do I split my 4 terms? Right after the negative 6ay, so right after the y before the minus, right? Right there. Look at your first 2 terms, the 6ax minus 6ay, and let's see if there's a GCF there. 6, right? 6 goes into both. So I have a 6 that I can pull out. Anything else? They both have a's, so I can pull an a out. That it? Yeah, because they don't have both have x's, they don't both have y's. So what would be left here? X minus y. I'm just trusting that you did enough homework, or you're comfortable enough with this for me to just go from here to here, and that's an okay step now. Now I want to stick with the way that I like to teach this. I want to match that over here, don't I? And what I need is for it to match exactly to be this, x minus y, right? I need it to be x minus y here and x minus y here. So the question becomes, what do I multiply here by to make an x become a what? A negative x. I need a negative 1, right? That's the only way to do it. You could just put minus, but I'm going to put negative 1. Now let's just double check it. If I multiply that through, negative 1 times x, right, gives me negative x, but then what's negative 1 times negative y? Positive y, and hey, look at that. It worked out perfectly, didn't it? That's because this grouping works on this one. I'll give you an example today where grouping doesn't work, and you'll see how You just get to a point where you're like, can't do it, can't factor it. But this did work. Go ahead. That's what I'm getting at. Yeah, I mean, you could, but here's the danger in that, okay? What if you were looking at this right here, and I said, what's a GCF? Well, what number, you would say there's a 1 there and a 1 there, right? So you say 1, so you say forget it, right? Then you say X and Y, they don't both have X's, they don't both have Y's, so you might think to yourself, there is no GCF, which would be correct, kind of, but -1 is a GCF. So it's harder. Do you see that that's harder to see? If you would have put 1 here, then you would have had X what? What would you have put inside? No, I didn't say bring down this sign. I did not say bring down this sign. I said whatever number is here is what will determine your sign. Like in the previous problem, we pulled a Y, right? Look at the previous problem. We pulled a Y here, and Y is positive, right? We didn't say -Y, we said Y. So that determined the plus. Okay, so when I'm here, I'm glad you brought that up. This sign right here is not going to determine this sign. What determines the sign here is when we put this here and we try and match it up, and then we forget the rest of the problem, we forget everything, we just say, how do I turn X into -X? Well, I need a -1, right? That's what determined I needed a -1. Okay? This is kind of tricky. That's why I want to show you this example. A lot of students will make a little mistake here with the sign. Maybe they'll put a negative here, but they'll leave that as a plus. Would that be correct still? If you pulled a negative like this, but then put plus in there? Well, first, these don't match, right? But then also multiply through. What's -1 times X? -X. What's -1 times Y? -Y. That's not even what you started with, you see? So you have to be extremely careful with the signs. Okay, that's where we are, right? Now, let's go ahead and recognize that we have that common thing in parentheses. So that's our new GCF. We pull that out to the front. Have to put in parentheses, right? Then what's left? 6a minus 1. What do you think? Yeah? Any questions? Yeah, as with mostly everything in life, things get a little harder, right? So let's try this. Let's try 14c minus 56 plus 7h C minus 28H. So I kind of do two things, all right? When I'm looking to factor something, like I almost simultaneously do it in my head. I say, how many terms and do I have a GCF? So how many terms? 4. So I'm already thinking in the back of my head, I might have to try grouping here, but I'm always going to look for a GCF first. So is there a GCF in this? Yes. Look at what number goes into 14, 56, 7, and 28. 7. Now how about letters, variables? I don't have C's throughout. I don't have H's throughout. So the only GCF I have right now is a 7. Correct? You've got to pull that first. Because 14 doesn't go into 7. So you're looking for the greatest one that goes into all. So I put that 7 out here. I give myself enough space for how many terms? 4, right? Because I started with 4. Okay, what goes in there? 2C. 8 minus 8, right? So negative 8 plus HC minus 4H. I think for that step right there, you kind of have to look at yourself in the mirror and be like, do I know how to do that? Can you do that? Like, you have to be honest with yourself. Are you comfortable with this or not yet? Because you have to get to that point, you know. Watching me is one thing. And don't, you know, if you're sitting there and you're still like, I have no idea how to do that step, that means you need to keep practicing more. It would, but your final answer would probably not be completely factored. I'm happy to show you that, if you remind me when we finish this. Show you what would happen had you not done this step first, okay? You can still get the right answer, but you'll see, okay? All right, y'all okay with that? We've pulled the GCF. Now inside the parentheses is like its own little world in here. We have 4 terms. There's no GCF in it anymore. So I try and do grouping. Where do I cut it? Right behind the 8. Now the problem is that we still have that 7 out there, don't we? So watch the way I'm going to deal with the 7. I'm going to put a 7. I'm going to put a bracket instead of parenthesis. The reason I'm doing that is because when I do grouping, I actually use parentheses. So I don't want to start mixing parentheses up. So I put a set of brackets. So it says 7 times whatever the hell I figure out the inside of that is. Now what is the first 2? What can I pull out as far as a GCF on the first 2 terms there? A 2, right? That's it? So I pull a 2. What's left there? C minus 4. Then I move to the other one, and here's where I'm going to play my matching game, okay? What do I need it to be? C minus 4. Is there a way that you can turn C into HC? H, right? Now, do I need it to be H or negative H? Just H, right? Because positive H times C would give me positive HC. So I'm going to put an H out here, and in front of it, I should put what? A plus, because it's positive. Does that kind of help that one step where you're asking where does that sign come from? I know it looks like it comes from here, but it won't always work that way. All right. Okay. Uh-huh. Okay, so what I did there is I looked at just this, and I said, what's a GCF for that? Well, 2 goes into both of those, right? So I pulled my 2 out right there, and then I had to do a set of parentheses so that I could reproduce the green when I distribute through. So 2 times what gives me 2C? Well, I'm missing a C. 2 times what gives me negative 8? I need a minus 4. Then I close it off. So this creates that. And then, yes? And then match it, and then try and come up with this right here. And then this will match. You can check it. H times C is HC. What's H times negative 4? Negative 4H. Mm-hmm. All right. What now? Yeah, so now we look at this matches this, right? So that means that I can factor it out, pull it out in front. But where's it going to go? I mean, the brackets create a separation between the 7 and everything in here. So what you need is, you still need the 7. You still need the brackets. And then you do that factoring out now, which would put your C minus 4 here. And then what went inside here? 2 plus H, which was those pieces in front that we're missing. That kind of makes sense? Some students prefer to do this. When they get to this step right here, Some students prefer to just take that inside problem, bring it over here, do it, and then come back and put it next to the 7. It's really up to you. I like to try and work at one line at, one line equals the next line equals the next line. Okay, now the only thing left to do, even though this is technically correct at this point and we are done, is to realize that this is multiplication here and multiplication here, which means we don't need the bracket. We needed the bracket earlier, and the reason we needed the bracket earlier was because, let's see if I can make this make sense. The reason we needed the bracket earlier, like even right here, was because we had a plus in between these two, didn't we? These two had a plus separating these two, but now that we've got it down to here, there's no more plus. And so it's just something times something times something. You don't need brackets to separate that. That kind of makes sense? So if I write like 2 times 3 times 4, I don't need to put 2 times 3 times 4, right? It's all the same. That one was a little more challenging, right? We had a GCF that we had to worry about. Here we go. Negative 30 BS to the 4th. I'm trying to make this work a certain way. Hold on. Yeah. Plus 15 BS cubed. T. That's a T, not a plus. Plus 6s to the 4th minus 3s cubed t. This will be our last example for this grouping method. And then we'll be done for the day in this section, and then we'll start the next section. Did you get excited there for just a minute or no? So nice outside, right? Who wants to be inside doing this right now? All right, so you look at it, and you hopefully think, how many terms? 1, 2, 3, 4. Okay, so I'm thinking maybe grouping, but I must first see if there's a GCF. What number goes in all those? 3 or negative 3, right? You can always look at it either way. Is that it? S. Good, you caught it. We have an S to the 4th. We have an S cubed. We have an S to the 4th. We have an S cubed. So how many S's do we have in common? S cubed, right? So I'm gonna let you decide. Would you like to have 3 or negative 3 as the GCF? How many want 3? Negative 3? Okay, there's not a wrong way, all right? It won't matter. I'll go with what more people would do just to do it. I'm gonna say 3, and then what did you say about the S's? S cubed, right? 3S cubed. So I'm going to put 3S cubed out here, and then in parentheses, let's turn 3 into negative 30. Multiply it by what? Negative 10. All right, I also need a B, but I don't have a B, so I need to introduce one, right? I need an S to the 3rd to become an S to the 4th, so I need S. So I've got some BS there, right? We have to find any humor that we possibly can, okay? Even if we have to really dig for it. All right, next term. How do I create a 15, positive 15 from 3? 5, so I put plus 5, right? How do I turn s cubed into s cubed? I don't need to, right? A 1, so we don't really write it. But I do need a t, and I don't have a t down here, so I have to put a t. Oh, b, yeah. Ooh, good. I'm glad you caught that. B. I forgot the b. 15b. I need my b here. Don't need any s's, but I need also a what? T. Thank you for catching that. That would have been big problems later. Questions? How do I turn 3 into positive 6? Plus 2. How do I turn s cubed into s to the 4th? S. I'm going to scratch my GCF out here, move it. I forgot to show you what would happen if you didn't pull out the... I'll show you in this problem, okay? Am I done with that third one? Yeah. Okay. So how do I create negative 3 from 3? Negative 1. I technically don't need the negative 1, but I'll put it there. How do I turn s cubed into s cubed? Don't need it. How do I turn, well, I need a t. I don't have a t, so put a t there. So I could put negative 1t, or I could just put negative t. It's up to you. I'm going to put just negative t. Any questions on that step? That's just the GCF step. No? Okay, now, I'm going to split this. And on my next line, I'm going to write the 3s cubed. I'm going to put a big old set of brackets around here. Best cough you. I don't know. What do you say? I heard that back, like that whole thing, bless you, that it comes from like way back in the day, like medieval times. Huh? Like way back in medieval times, like if people were like coughing, sneezing, it usually meant like you're going to die because they didn't have modern medicine and stuff. They're like, bless you. Goodbye. I don't know. I've just heard that, so who knows. I've also heard that thunder is God bowling, so I don't know. I mean, some things you got to kind of have a little bit of doubt. All right, what do we do on these two right here? GCF, holy moly. Okay, so any numbers that go into both 10 and 5 will negative 10 and 5? 5 or negative 5, right? I could use either one. I think everyone's been comfortable doing the positive one, so I'm just going to stick with the positive one. What about letters? Any letters common in these two? B, that's it, right? So I'm going to take a 5B as my GCF, and I'm focusing just on the first two. Is that all right? Yes? So I'm going to pull a 5B, parentheses, enough space for two terms. Turn your 5B into negative 10BS. So 5 into negative 10, negative 2. I have a B already, but I still need a what? S. Is that all with that one? Okay, now let's get our 5B to become 5BT plus 1, and I'm only missing a T, right? Plus T. You can always check these, right? All you have to do is just multiply them through. They better match up with those things. Okay, now here's where I think this would be a good time to stress again that whole idea of trying to match things, right? What am I going to try and match up with over here? What am I trying to get? Negative 2s plus t, right? That's what I'm trying to get here. And I have this, so how do I turn negative 2s into positive 2s? I need a negative 1, don't I? How do I turn positive t into negative t? I need a negative 1. So that negative 1 will come out in front, and I put a negative on it, right? You see it? Does that work? Do you all agree that that will work and create that up there? I made this example specifically to illustrate how you can't just look at that one sign. If you would have thought, okay, because I have 4 terms and there's a plus here, that's going to force this to be a plus, I just gave you an example where it doesn't work that way. Do you see that? That's what you were bringing up earlier, right? So you just have to be careful. Now, I could have got it to work had we pulled a -3 out in the beginning, but that's neither here nor there. This is what we did. The things on the inside there, let's work with that. 3s cubed bracket. The inside turns into what? -2s plus t in parentheses. And then 5b minus 1. Do I need the brackets anymore? No. Do you see how important what we did at the end of class last time was? Where you recognize that same thing in both and pull that out? I mean, without that, this becomes extremely, difficult. Because you're constantly confused on this step. And if you still are constantly confused on this step, you need to make sure you come sit down with me or a tutor and make sure you get that all worked out mentally so you feel good about it. All right? We're done. Yeah, I do. Here's that same problem, right? Okay, let's just act like we forgot about the GCF in the very beginning of the problem. So I split it right now. What's the GCF here? So what number goes into both 30 and 15? 5 bigger? 15, right? 15 goes. Now I could use positive or negative. Let's just go with positive. It seems to have treated us well at this point. 15. How about B's? How many B's are common? Got 1 B in each one, right? How about S's? S cubed? That all? Yeah, because T's, they don't all have T's. So then what would be left in here? You're trying to turn 15 into -30. -2. Then just S. You're trying to turn B into B. You already have it. S cubed into S to the 4th. You just need an S, right? So I've got the first one. This one, how do I turn 15 into 15? I've got it already, right? B to B, I've got it. S cubed to S cubed, got it. Just a T, plus T. Now let's do the other two. We have to try and figure out how to match this. -2s plus T, right? What will I have to factor out there? Or what will I have to put in front here to make this happen? So be careful. We're trying to turn -2s into +6. How do you turn -2 into +6? -3. Okay, how do you turn S into S to the 4th? S cubed. And that's it, right? That should turn the -2s into this. Does it turn the other one into what we need it to be? -3s cubed times +t gives me -3s cubed t. So it works. But now we need to go to the next step, which would be to take our things that match, pull them out front, or pull it out front. What would be left? 15bs cubed minus 3s cubed. Here's the danger. You box that and you say that's your answer. Here's the issue. This one doesn't have anything in common, right? No GCF here, but look at this one. You have a 3 that goes into both, and you have an s cubed. So you'd have to pull a 3s cubed out of that. So if you box that, it would be partially factored but not completely factored. So if you recognize that, you could take this and say, oh, okay, that is 3. I pull a 3 out, pull an s cubed out. I'm left with 5b minus 1, right? You agree? And then what do we have sitting in front of that? Negative 2s plus t. Does that look like our answer before? If I move this out here, is that the same thing? That's the same thing. See? So it can be done, but in my experience in doing this, a lot of students forget that final recheck of GCF at the end. So if you forget to do it in the beginning, I'm not real confident that you're going to remember to do it at the end, you know? So I just say do it in the beginning. Okay, questions? Yes. I'm not. I'll give you bonus for it, but I forgot the sheet. So what I need is someone to volunteer to sacrifice a page. Who's doing it? Got it? Just put the date on top of it and just put your name and start passing it around. When it gets to you, put next to your name bonus. Not everyone do that. That's not. That'll confuse me. So I was talking about God bowling, right? I know everyone's like ready for the weekend. This is water, okay? Has anyone ever jumped into a pool or thrown a rock into water, things like that? All right. What usually comes up out of the water after you throw something in or you jump in? What goes to the surface? The splash comes out, right? But then after like a few seconds, you start seeing what come up? Bubbles, right? Bubbles? Okay, so when you jump into the water, right, let's just say it's a rock. You throw a rock into the water, right? What happens is that the rock, when it hits the water here, the water has to move out of its way, right? Has to move. So it's pushing the water out of the way. I'm going to have to redraw my whole line. This is my water. So now the rock is here, right? It's physically moved the water out of the way. And then as it moves, let's say this is, a couple of seconds later, it's now something like this. Right? Now what's happening behind it? What's happening with that water? It's starting to cave in and get closer together, right? When it does that, right, maybe at the next instant in time, whoa, the rock's down here, right? And the water has now come back together up here and it's touched together, but it kind of clipped off that air that was behind the rock, right? And maybe there's some other pieces of air that got trapped behind it. And then the rock proceeds to keep going to the bottom, and then what happens is that air has to float up to the top and you get the bubbles, right? And if you just take a rock and you go up to the surface of the water and you just slowly let it go, it'll fall and you probably won't get any bubbles because as it fell, the water closed behind it very fast, right? But if you throw a rock into the water, what happens is it punches a hole into the water, splits it open, and then the air gets trapped behind it and you get a lot of bubbles. Does that kind of make sense? Okay. So imagine throwing this rock really fast into the water. If I threw it fast enough, it would do that, and then eventually it would snip off at the top, and you'd get all that air has to come back up. Okay. That's a house. Okay. You have lightning, right? We'll do yellow. Lightning, right, comes down, hits the ground or something. Now, water, we understand water. You put your hand in a pool, you can feel the water, right? How about air? Move your hand. You feel it? You ever stick your hand out the window of a car at 60 miles an hour? Done that thing that's real fun to do, up and down? You've done that, right? It's really cool. Right? The air is there. It's just like water, but it doesn't resist things as much as water. So what happens with lightning is lightning, when it's a bunch of electrons Supercharged electrons. Did you get your text? Oh, no. The bolt of lightning comes down into the ground, and it's so hot, it vaporizes the air. So it's like a rock thrown through water extremely fast, and it creates a column of an emptiness behind it, just like the rock does. Except instead of it being water coming together, it's what? It's air. It's the atmosphere. It's a huge column of air that has to come back together. And when it comes back together, it makes a sound, and that's thunder. The thunder is the atmosphere trying to come back together to fill the void behind the bolt of lightning. And so you get this rumble, boom. That's what it sounds like when the atmosphere closes on itself again. Kind of cool, right? So for every bolt of lightning, there should be thunder if you have an atmosphere. So you'll never like hear thunder and there was no lightning, you know? One has to go with the other. Little FYI thing. Or if you prefer God bowling, that's cool too. Whatever you like. Whatever makes you happy. 6.2. That was 6.1. Yes, last class was 6.1. So we basically know GCF and we know grouping, right? That's the techniques. Your homework, I'll give you your homework at the end. This one we're going to it'll go pretty quick, I think, and we'll be out of here, don't worry. This is factoring binomials. In 6.1, the GCF worked on anything not worked, but we could always try GCF on everything we saw. And then if there were 4 terms, right, we tried grouping. This section is just about 2 terms, how you factor things with 2 terms. And you might be saying, well, why would I do 2 terms after 4 terms? Well, it just turns out that the 4 terms is easier to look at. This, we just wait and do it next. Okay, so I know the order seems weird, like starting with 4 terms and going back to this, but that's the way we do it, all right? So remember what factoring meant. Factoring meant going backwards. Instead of multiplying 2 things together, you start with something, you try and turn it into multiplication. So I'm going to put a couple of things up here, and I want you to start to notice a pattern. Hopefully, you'll see it. What if I take this binomial, x plus 1 times x minus 1, 2 binomials, right? And I multiply them, what would we get? X squared minus 1x plus 1x minus 1. What happens to the middle terms? Minus x and plus x cancel, don't they? And so all you're left with is what? X squared minus 1. Let's try another one below this. What's x plus 2 times x minus 2? X squared minus 2x plus 2x minus 4. So if you do those things again, right, you get that. What happens to the middle terms? Again, they cancel. So all you're left with is x squared minus 4. What would happen if I take x plus 3 times x minus 3? X squared minus 3x plus 3x minus 9. The middle terms cancel, I get x squared minus 9. Do y'all see this pattern? If I have something plus something times that same thing minus that something, right? That it appears what happens is that all you get is whatever was here squared, and then whatever number this was squared over there, and minus between them. Yay or nay? Okay, so what about this? What's a plus b times a minus b? Well, you could do all the working out of it. You get a squared minus ab plus ab minus b squared. That would turn out, because the middle terms would cancel, to be a squared minus b squared. Y'all see the pattern? This final one down here is where we get a formula from. It's called the difference of squares formula. So here's the formula. Difference of squares. It says this. If you have a squared minus b squared, so if you have something that's being squared and you subtract something else that's being squared, so do you see why it's called difference of squares? Difference meaning subtraction. You have the difference of squares. That this will always turn into a plus b times a minus b. Without you doing any work. You don't have to do GCF. You don't have to do any other thing. Just identify the two things here, and you just plug them into this formula, and you are done. All right? Now, I like to do a little bit more than that. I like to actually write a in parentheses squared minus b. Doesn't like that. And maybe you'll see, as I do some examples, why I prefer to put the a and b here in parentheses instead of just a and b like that. It's the same thing, though. So I'll probably refer to this. All right, let's see how this works. You'll be allowed to have that formula on the test, on your cheat sheet. That's okay. So as an example, if you're asked to factor x squared minus 121, you look at it, and because I said factor, the first thing you do is you say, I have two terms, do they have a GCF? Is there a GCF between these two terms? One, right? So there's nothing I can do. It's two terms, not four terms. I'm not going to try grouping. Two terms, whenever I have two terms now, right now, as of today, we have the difference of squares formula. So I think to myself, okay, well, maybe it looks like this. Maybe it looks like something squared minus something squared. If it does, then I know it's this, a plus b times a minus b. So do you have something squared minus something squared? Well, x squared, isn't that just x squared, right? Minus, now, what about 121? Is that something squared? Hmm. 11 squared. It's 11 squared. 11 times 11 is 121. So if you didn't know that, you might have to get on your calculator and try a couple of numbers. So 121 is 11 squared. Now do you see that we have something squared minus something squared? What's a for us here? X. What's b? 11, right? Not 121, 11. So that means, according to this formula, this should turn into what? A plus b. So x plus 11, and then a, which is x, minus 11. And that's it. You've turned subtraction of two terms into multiplication, which is what factoring is about.
So you don't keep the squared, take the squared.
Yes, that's right. You only want the part that, the base, the thing that's being squared. That's your a. The b is the thing that's being squared. So the square won't appear anywhere over here. Because the way you get it back is you multiply this times this, right? And when you do that, you get x squared. If you had put squared over here, now you get like x to the fourth or something. Now these can get kind of tricky. Like if I have 5x squared minus 125 y squared. What do you think? How many terms? What's the next thing you should ask yourself? Greatest common factor. Is there a greatest common factor? 5. If you miss that step, this problem's not going to be easy. You've got to see that there's a common factor of 5 first. So let's go ahead and pull the 5 out first. If I pull a 5 out, what am I left with? X squared minus 5 times what gives me 125? 25. And then y squared. You'll see that? So I pull a 5 out of both terms. Now, look at the inside of that parentheses, and tell me, that has 2 terms, right? Does it look like a difference of squares? Does it look like something squared minus something squared? Yes? Okay, what's the first one? The first one is just x squared, right? X squared. So watch the way I write this. I'm going to write 5. That's really just x being squared, right? That's what that is. But now my minus. What is this down here? It's 5y being squared. This is the part that's tricky. If you square, see, this is a property of exponents we learned a while back. If you have two things being multiplied and you square them, don't you square them both? Yes? So you square the 5, it becomes 25. You square the y, it becomes y squared. Why is this? Why? I guess what I'm getting at is if you do it this way, what's a? In the formula up there, what's a for us here? X. And what's b for us here? 5y. If you say that b was 25y, it's wrong. Because the 25 is not being squared, is it? In this, the only thing being squared is the y. You have to rewrite this so that it looks like something, the whole thing is being squared. That's why I like to put the parentheses so that in the formula, because then you're forced to kind of say, okay, the whole thing has to be squared, not just the end piece, not just the y squared, but what's in front of it has to be looked at as being squared too. I hope that makes sense. So for us, a is this, and b is this. So what does our formula say? It should turn into a plus b, parentheses, times a minus b. But sitting out in front of it all is a what? A 5. So I have 5. Here's my difference of squares formula. A for us is x plus now b, 5y, and then x minus 5y. The 5 that came out, parentheses, a plus b, close, open, a minus b, close, done. What do you think? Last one, I promise. Then we're out. X cubed plus 7x squared minus 4x minus 28. Factor it. Isn't factor now becoming your second favorite F word? Or is it moved up to number 1 now? What are you thinking when you see this? GCF, okay. Is there a GCF right now? Nope. I don't have X's in all of them, right? The last one's missing an X. I almost had it. No numbers go into all of them? What's the next thing you're thinking since there's no GCF? Factor by grouping because there's four terms, right? So you come and you slash it where? Right behind the 7x squared. You take those first two terms and you try and find a GCF here. What's a GCF out of that? X squared. You pull that out front. What's in front? What's inside there? X plus 7. Good. Now we need to match that on the other side, right? Match it up and hope for the best here. I need x plus 7 here. How am I going to turn x into negative 4x? Minus 4? Does it work? Let's just check. Negative 4 times x is negative 4x. What's negative 4 times positive 7? Negative 28. Yes, so I'm happy. Now go to the next step of grouping, which is to take what we had in common, pull that out to the front, and what are we left with? X squared minus 4. Box it up, we're done? Yes, you can. Look at that. What's that? What's x squared minus 4? It's two terms, right? X squared minus 4. And x squared is squared, and 4 we know comes from 2 squared, doesn't it? So this is actually a difference of squares. So that means it can still be factored. This can be broken down. This one is not a difference of squares. This one is. And that's going to become part of a challenge for you, is being able to get to a point and recognize, oh, wow, I still have something there that I can work on. Because, again, if you stop here, it's not completely factored. So I'm going to rewrite the next line as x plus 7. I like to use those parentheses. X squared minus what squared? 2 squared, right? So I'm realizing that 4 really comes from squaring 2. And then by doing that, I can recognize what A is, and I can recognize what B is. So I know that this thing in here is going to turn into two sets of parentheses, right? A plus B, A minus B. But sitting in front of it is still what? X plus 7. So I have x plus 7, and now here comes my two sets of parentheses from difference of squares. X plus 2, x minus 2. Now you are done. This is two terms. There's a minus. Why is this not difference of squares? X minus 2. Well, x isn't being squared, right? So we're done. We're not done with 6.2 because there's two more formulas. We have a formula for difference of cubes. That'll look, I'm not going to write it all down, but it'll be what happens if we have this. There will be another formula for sum of cubes, so if we have that, and we will learn that for squares, we have a formula, difference of squares, right? But it turns out for, if there's a plus between them, it turns out that there is no formula when you have a plus between them. We'll see that, but that's where we still need to go here. Here's your homework. It's actually quite a bit of homework. I'm going to give you the same instructions I gave my other class. Factoring is so important that my plan is starting on Tuesday, you will have a quiz at the beginning of class every day over your homework. It'll be 1 to 2 problems, maybe 5-10 minutes. Factor this. I promise I'll keep it within the realm of what the homework is asking. But I need to see every day that we do factor. I need to see that you are up to speed with what we're doing. All right. So expect a quiz on Tuesday, and expect it to cover homework. Okay. So the first section up there, that's going to be grouping. Okay. These are difference of squares problems, and 23 might be just a little bit nasty. I mean, there's nothing crazy about it, but this one is harder than these. That's all. Everyone have a great weekend. The a squared, yeah. You just need the difference of squares formula? God bless, what's going on with this thing? That's the only formula I've given us. Yes. I don't. Well, you know what? Hold on. You said yours was in the other class, right? Then I probably do. Yep. I probably have it then. I brought their folder, not yours. What's your last name again? Have you looked online to see your grade? Through Canvas? No? You go in, you know what I'm talking about when I say Canvas? So go to like My Courses, click on this class, and then it'll bring up like this blue screen. And then on the left it's like grades, files, syllabus. Click on grades. Interesting. I'll look at that. It shouldn't be that way.